Hi everybody. Today I'm going to show you how to find eigenvalues and eigenvectors of a 3 by 3 matrix. Let's move ahead to see how we can deal with this. We shall calculate determinant of m minus lambda I. We took this m minus lambda I from vector equations. If you want to know in details of these equations, then you can visit my YouTube site on eigenvalue and eigenvectors for 2 by 2 matrix. So in these situations, I can write m minus lambda I equal to, this is M matrix, this is identity matrix. Both matrix are same size and there is a lambda. This is actually eigenvector. This is actually eigenvalues. This is values, eigenvalues. Now, if we subtract, so we'll find change in the diagonals. All other positions will be as it is, because in identity matrix these are 0, here these are 0, only diagonal is 1 1 1. So if we do subtract, so this 4 and this 4 will come with minus lambda, this, and other 3 here, it will be same as this. Here other 3 will be same as this. So keep it in mind, to do the matrix work faster, we should know this. Now in determinant form, we can write like this. To calculate, we have to look at which ways it will be easier. Like here, second row, there is 2 items, third element is 0. And this third column, middle element is 0. So we can take either this one or this one to find the determinant. Let's take this one, third column. So 1, and here cofactor will be this, because one this column and this row will be cancelled. So we have only this 4. So minus 2, 4 minus lambda, minus 4, 3. Same way for 1 minus lambda, we shall cancel this, we shall cancel this. So these 4 will take. That's what it is done. So here we write like this. Now with more simplifications, we get this. Even we can go more simplified form as this. Now, as we know, determinant a minus lambda I equal to 0. So we can write this a minus lambda I equal to 0. This is actually the characteristic equations. So this is the characteristic equations. Now this cubic, after factorizing, can be written as this: lambda minus 2, lambda minus 3, lambda minus 4 equal to 0. So our eigenvalues are 2, 3 and 4. Using these eigenvalues, we will find eigenvectors. Next slide, we'll see that. First, we will take eigenvalues lambda equal to 2 to get eigenvectors. So we can write as this one. This is matrix M, this is X vector, this is also X vector. So our equation is M X vector equal to lambda X vector. Lambda value we put here 2. Now we are bringing this on left hand side, keeping right hand side 0. So it takes form like this. Additional things we did here: M minus lambda identity matrix I. So M minus 2 identity matrix, 2 means lambda, and this is X vector, common for both, equal to 0 vector. And after subtraction, it takes the form as this. This is X vector, this is 0. Now we can make 3 equations looking at this, because 2 minus 1 1, and with x y z we can make equation 2x minus y plus z equal to 0 with second row, and with this x vector we can make equation like this. With third row, with this x vector we can make another equation. So we got 3 equations. So we have to solve this now. So taking equation, because in last slide we had 3 equations, so we are taking one equation, simplest one, minus 2x plus 2y equal to 0. So easy way, we get y equal to x. Now we have to assume x equal to t. to get the things in generalized form. So x equal to t means we can write y equal to this x place, we can write t, so it will be y equal to t. Now we got x in terms of t, y also we got in terms of t. Now we need z in terms of t. So what we will do, we'll bring another equations from previous slide, this one. Putting the value of x and y, we get the value of z in terms of t, and we got it, z equal to minus t. Now in eigenvector form, we can write x equal to, this is the value of x, this is the value of y, this is the value of z. So it comes, if we take t out, then inside 1 1 minus 1, this is the eigenvector using lambda equal to 2. Now we will find eigenvectors using eigenvalue lambda equal to 3. So we can write as this, like before. This is M matrix. This is x vector equal to lambda x vector. Lambda here we are considering 3. So we can write like this. Now we will bring this right hand side in the left. And adding an identity matrix. Otherwise we cannot subtract it. If we don't put identity matrix, we cannot subtract. That's why we do that. So now this is the form. We have to do subtract from this matrix minus of this. It takes the form as this after subtraction. Now we can make 3 equations. This is first row with these vectors, second row with these vectors, third row with these vectors. So we got 3 equations. Now in next slide we shall take equation one by one to get the values of y, x and z. So taking equation, this simplest one, we get y equal to 2x. Assume x equal to t, so we get y equal to 2t. This is second equation from previous slides. Then z equal to minus t plus 2t. Putting these values, then we get t. So we got values of x t, y 2t and z equal to t. Now we can write eigenvector as x equal to value of x, y and z. Taking t out, it comes, eigenvector comes as 1, 2 and 1. So this is eigenvectors. Now we have remaining eigenvalue lambda equal to 4. So to get eigenvectors, we'll use this lambda equal to 4. So we can write as like previous m matrix x vectors and 4 multiplied by x vectors. This is M matrix. Bringing this on left, putting here identity matrix with lambda. Now we can subtract. So it takes the form as this after subtractions. Now we can write 3 equations. First row with these vectors, we get this equation. Second row with this vector, we get these equations. Third row with these vectors, we get this. So we will take this equation one by one in the next slide to find the value of x, y and z. So we'll take equation the simplest one. So easily we can find x equal to 0. And using another equations we can find y equal to z. As well, using the third equations we can find also y equal to z. Now we have to assume y equal to t, then z will be also t, because here we know y equal to z. So if y t, z will be also t. As well we know x equal to 0. So now eigenvector is 0, t and t. T taking out, it will be 0, 1, 1. So we got the eigenvectors. And that's all for today. Thanks for watching.